All right, folks, we are going to take a look at quadratic functions, and specifically we're going to be taking a look today at a, h, and k. We're going to be finishing up our understanding of quadratic transformations. So first off, this is an online calculator called Desmos. It's pretty powerful, it's pretty cool. If you ever want to use an online calculator or online graphing calculator, this is one that I recommend. www.desmos.com. So let's take a look at what we got here. So here in blue, we've got our quadratic parent function, y equals x squared. So we've got our quadratic parent function, y equals x squared, and then we're also got our vertex form, which is y equals a times x minus h squared plus k, which is written right here in red. So we've got two functions. Let me put my graph back. We've got the parent function in blue. We've got our vertex form in red. And one of the really cool things about Desmos is it allows us to have sliders. So remember I told you that a, h, and k are coefficients in our vertex form. When we graph this, when we do anything with this, a, h, and k need to be numbers of some kind. So let's take a moment and just kind of recap what we talked about last time. If a is 1, h is 0, and k is 0, then what we end up with is the parent function, because that goes away. This simplifies. X minus 0 is simply x. So it's 1 times x squared, which is exactly what we have here. We have 1x squared. So let's do that with our sliders. So we have a, h, and k. So currently our a value is 1, h is 4, and k is 0. So if I take this, and remember we want h to be 0, so if I come here to my slider and I pull this over and make it 0, 1, 0, 0, oh, I hit the wrong thing, sorry. Let's go back, because I hit a button. I hit a button with my finger. There we are. So 1, 0, 0, a, h, and k. This is the parent function. Now let's talk about specifically, let's start with k and then we'll work our way up. If you work through the handout from last time, the worksheet, you know that the k does what? When we change k, what happens? Is there a vertical shift of the vertex or horizontal shift of the vertex? Does the parabola get wider or narrower, or is there a reflection over the x-axis? If you remember correctly, you know that this is going to be a vertical shift. So let's take our slider. Let's take our slider and move this. So I'm going up to 4, so that's a k value of 4. So when k equals 4, it has risen 4 units. We can slide it down. Now my k value is negative 5, negative 5.3. Sorry, my touch screen is real sensitive. Okay, so k, sliding k, changing the value of k, slides the parabola up and down. Notice it doesn't, it looks like it gets narrower, but it actually doesn't. It's the exact same shape as the parent function. It simply looks like it's narrower because you're seeing more of the function, but it's the exact same shape. It is not getting wider, it's not getting narrower. It's simply translating, it's simply sliding up and down the y-axis. So let's put that back at 0. Almost at 0. Okay, we'll leave it right there. It's really close to 0. Let's see if I can make it 0. Sorry, that's going to bug me if I don't make this 0. Okay, good. Now, what does h do? Is that a vertical translation or horizontal translation, wider, narrower, or a reflection over the x-axis? If you remember correctly, this is going to be a horizontal shift. When I make h positive 4, it translates positive 4 on the x-axis. If I translate this, if I move the slider to negative 2, it changes and translates negative 2 units to the left. If I move h, if I make h negative 8, then it translates or it slides 8 units to the left. H makes the function go left and right. K makes the function go up and down. That's right. Now, so K was our vertical translation of the vertex. H is our horizontal translation of the vertex. Hopefully you remember from last time that A makes the parabola become wider and narrower. So compared to the parent function, remember this is the same shape and size as the parent function, what does, when I make A bigger than 1, when A is greater than 1, what happens? It gets narrower. It gets narrower than the parent function. Now notice right now the parabola is getting wider. It's getting wider, but I'm still narrower than the parent function. My A value is still above 1. It's still greater than 1. When my A value is 1, it's exactly the same size and shape as the parent function. And when my A value is less than 1, it gets wider. It gets wider. Now look at that right there. See the red line? The parabola actually became a straight line when A equals, see if I can get it to stay. Nope. My touch screen is too sensitive. That's too bad. Let's see if we can actually see it if I get my finger on it. What's A? A equals 0. A equals 0. We'll talk about that one day. But what happens when A becomes negative? It flips over the x-axis. This is a reflection. Now because A is still less than 1, or the absolute value of 1, it's between 0 and negative 1, it's wider than the parent function. As soon as I get to negative 1, this is the exact same shape as the parent function. It is neither wider nor narrower than the parent function. It's simply reflected over the x-axis. But once I take A and make it greater than negative 1, I'm sorry, if I make it less than negative 1, so that it's farther and farther away from 0, then the parabola gets narrower and narrower. A makes the function become narrower and wider, as well as reflecting it over the x-axis. In today's class, what we're going to be talking about specifically is if I leave the parent function here as the blue function, then what we're going to be doing is I'm going to give you different values for A, H, and K, and I'm going to expect you to be able to describe the translation that occurs. So for instance, the red parabola has translated 6 units to the right. It is translated, or shifted, a vertical shift of 4 units up, and it has become narrower than the parent function. We're going to finish out the rest of the problems in our assignment today. We're going to have an exit ticket at the end of class, and we are going to end our day. Hey, Bubba. Say hello to my class. You want to say hello to my class?
What kind of class is it?
This is my work class. These are for this. I'm making a video for my students so they can watch it in class.
Why, Daddy?
So they will have something to learn on Thursday and Friday.
Well, Daddy, what is learn?
What is learn? It's something you do every day. Whenever you find something out new that you didn't know before, you're learning something. What did you learn today, Benjamin?
But Mommy, Daddy, I know we're going to Myron White's house tomorrow.
Oh, you learned you're going to Myron White's house tomorrow?
Mm-hmm.
Yes, that's true. You did learn that. That's a good job. All right, class. I will see you in class. Say bye-bye, Benjamin.